Assalamu alaikum.
Hello. Assalamualaikum.
Walaikum salam. How are you, Shavi?
I'm good.
I hope you are doing well. What about your health?
I'm fine, thank you.
Okay, that's good. So, should we start our today's lecture number 7?
Yeah.
Let me share my screen with you. So my screen is sharing with you.
Yes.
All right. So, today is our lecture number 7. And in this lecture, basically, we will discuss about an important concept in physics, which is the Newton laws of motion. Have you ever listened about these laws of motion before?
Yes.
Okay, where?
In school.
In school. Okay, so your classes started.
Yeah.
Okay, so you are taking physics classes in school as well, right?
Yeah.
Okay, that's good. So in today's lecture, we will discuss the same concept of Newton laws of motion. So before that, can you tell me how many laws of Newton are there in total?
Three.
Yes, three laws of motion. So our today's objective is this. We will discuss briefly all three laws of Newton's. Okay. Our learning
Mhm.
objectives, we will all state and explain what are those three laws of motion, and then we will understand how our forces affect that type of motions. And then we will discuss an important formula which is used in second law of Newton, which is F equals to ma, and we will solve some real world example problems related to this. So now let's move on. Starts with the Newton first law of motion. Basically, Newton's first law of motion tells us that if a body is at rest, they always remains at rest. And if a body is moving with constant or uniform motion, they always remains in uniform motion until no external force provided. Okay, so
Mhm.
let's suppose if a body is at rest, they always remains at rest. Okay, they never accelerates, they're not gonna be in motion until you provide an external force, and when you apply some external force to that body, then the state of the body changes from rest to motion. And if a body is in motion, let's suppose they are in motion, and if you want that body to be at rest, what you have to do?
Do you have to balance out the forces? No.
Uh, let's suppose if a body is in motion and you want that body to be at rest, what you have to do? Isn't you
Uh,
apply some external force to stop that the motion of the body?
yeah.
Yes, so you must have to apply some external force. So this is the concept of Newton's first law of motion. They tells us that if a body is at rest, they always remains at rest. And if a body is at uniform motion, they always remains at uniform motion until no external force applied to it. And whenever you apply external force, you know that the state of the object changes from rest to motion, and you can also change from motion to rest. Is it clear?
Mm-hmm.
Okay, so this is basically the statement of Newton's first law of motion. And there is another concept in Newton's first law of motion which is important, and we say that this concept as law of inertia. Sometimes in paper the question asks what is law of inertia. Basically, law of inertia is same what we state in Newton's first law of motion. Basically, inertia is basically the tendency to resist the change in motion. Okay,
Mm-hmm.
the more the tendency to resist, the more the inertia the body have. Let's suppose if a body is at rest and you apply some external, very large external force. So, can you tell me the inertia is high or low?
Uh, low.
If you apply more external force, the inertia should be high
Mm,
because the more you resist, the more the inertia the body contains. All right.
mm-hmm.
So let's suppose if a body is in motion and you want that body to be at rest, so you know that you have to apply some external force. If you apply more external force to stop that body, then this means you have to apply more inertia or low inertia.
More.
Yes, more inertia. And if a body is moving with low speed, then definitely you have to apply less force to stop that body. In that scenario, the inertia would be larger or smaller?
Smaller.
Yes, smaller. So is it clear?
Yeah.
Yes. So examples, another example is let's suppose a book is on table. They always remains stays at rest unless you put or you apply some external force to that book. So this is all about the Newton's first law of motion. So the key points which I also told you already told you, the heavier the object, the more the inertia is. Okay, inertia basically depends upon the weight of the object. The more the weight of an object have, the more the inertia it would occur. Okay.
Mm-hmm.
Inertia also depends upon mass. The more the body is containing mass, the more the inertia they attains. And if no net force acts on an object, then what should happen? If it at rest, then it will always remains at rest. And if a body is moving with constant velocity, they always remains at constant velocity when there is no net force act on the body. Definitely when you are not applying some external force to some body, if that body is at rest, they always remains at rest. And if a body is in constant velocity, they always remains in constant velocity.
We'll see.
Okay. So, is there any question regarding Newton's first law of motion?
No.
Okay. Now move on towards our second Newton's second law of motion. This is an important law. This tells us you that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to their mass. Means if your
Mm,
body is having more acceleration, then this should be directly proportional to the net force. What does this mean? If you apply more external force, can you tell me the body will accelerate more or less?
more.
Yes. And if you apply less force, the body will accelerate less or more?
Less.
Less. So this is all about the Newton's second law of motion. There tells us you that the net force you apply is directly proportional to the acceleration. The more the force you apply, the body will accelerate the more. The less the force you apply, the less the body will move. This is the direct relation between the applied force and the acceleration. But the statement also tells you that the acceleration is also inversely proportional to the mass. Can you tell me what does this inversely proportional means?
Uh, is it the opposite way or something?
Yes, opposite weight. It means if acceleration is high, the mass is low. If acceleration is low, the mass should be
Hi.
high. So the relationship between acceleration and mass is inversely relation. So simple thing is that if a body has greater mass, they will accelerate less or more.
Less.
Yes. And if a body has less mass, they accelerate more or less.
Less.
That's why the speeding cars, the racing cars, can you tell me their mass remain small or high?
Uh, Small.
Yes, we remains their mass as less as possible. Whereas you can compare it with the truck. Can you tell me the truck would accelerate more or less?
Less.
Less. Why? Because
It's bigger.
yes, it's bigger because the truck has more mass as compared to the racing car. All right.
Mm-hmm.
So we conclude that two things, the acceleration is directly proportional to the applied force, and the second thing is that the acceleration is inversely proportional to the mass. This states according to Newton's second law of motion. And Newton's second law of motion formulated their formula, which is force equals to mass times acceleration, F equals to ma. You have to remember this formula. Okay, F equals to
Uh,
ma,
MA.
where F is the force which you apply,
Mm-hmm.
it is the external force which you apply to the body. M is the mass of the body
Mm-hmm.
on which you are applying the force, whereas A is the acceleration. When you apply force to some body having some mass m, and that body now start moving with some acceleration a. So this is your complete formula for Newton's second law of motion, F equals to ma. So this is the formula, but we also have to explore the unit of force. So do you know what is the unit of force? How can we?
Newton.
Yes, newtons. The unit of force is newtons, and it is denoted by capital N. All right,
Mm-hmm.
perfect. Any question regarding to Newton's second law of motion?
No.
Okay. Uh, if all right, then we have some worked examples. So the first one is, what is the force required to accelerate a 3 kg object at 5 meter per second square? So first of all, can you tell me what it's asking for to find?
The force.
Yes, what is the force? Means you have to find the force. And what things are given?
Acceleration.
Yes,
Or
acceleration is given, which is
and the
equal
weight.
to,
Uh, 5 meters per second.
yes, 5 meters per second. Why not 3?
Because three is the mass.
Yes, mass. How you know 3 is the
Because
mass?
it says kilograms.
Yes, from its unit, kilogram. Perfect. So the acceleration is 5 meter per second square, and the mass is given, which is 3 kg.
Uh,
So they are asking you to find the force. And simple, you know that what is the formula of Newton's second law of motion, F equals to ma. By using that formula, just putting the value of m equals to 3, a equals to 5, 5 3 is 15, and you know what is the unit of force, newtons. Okay.
mhm.
Next problem. A 500 Newton force is applied to a 100 kg object. Find the acceleration. So, what things are given in this statement?
The force and the mass.
Yes, the force and the mass. And they're asking you to find
Acceleration.
acceleration. How can you find by using which formula?
Uh, F equals ma, and then just switching the A and the F.
Yes, by just switching and by substituting. So, A becomes equals to F by M, right?
Mhm.
So F in numerator, which is 500, and mass, it is in the denominator, is 100. So by just putting the values 500 divided by 100, you will get your answer, which is 5. And you must have to apply the unit. You know what is the unit of acceleration?
The meters per second squared.
Yes. And can you tell me what is the unit of velocity?
Meters per second.
Yes, perfect. Now move on to us. Third example, an object of mass 2 kg accelerates with 6 meter per second square. Find the net force. This net means
Uh, I can't remember.
total force. Okay. Whenever you see the word net, it means total. Okay.
Or,
So again, it's asking you to find the force, applied force, if an object having mass 2 kg and that object accelerates with an acceleration of 6 meter per second square. Using formula according to Newton's second law of motion, F equals to ma. By just putting the value of mass, which is 2, acceleration, which is 6 multiplies by 2, you will get your answer, which is 12
12 newtons.
newtons. Yes. The fourth one is a toy car of mass 0.5 kg is pushed with a force of 4 newton. What is its acceleration? So again, two things are given. What are those?
Mass and the force.
Mass and the force. And they're asking you to find the acceleration. Again, you know what the formula F equals to ma. By just substituting for value of a, you will get a becomes equals to F divided by m. F is 4 newtons and mass is 0.5 kg. By just dividing, you will get your answer, which is 8, and the unit of acceleration is meter per second squared. The last problem, a body moves with an acceleration of 3 meter per second square when a force of 9 Newton is applied. What its mass? They're
uh,
asking you to find,
Mass.
yes, mass, acceleration, and force is given. How can you
Mm-hmm.
find?
Equals F over A. But you just F equals MA and then just switch the M and the A. Or the F and the M.
Yes. So F is 9 newtons divided by acceleration, which is 3. So 9 divided by 3 becomes 3. And what is the unit of mass?
Kilograms.
Kilograms. So this is how you can solve problems regarding to according Newton's second law of motion. Whenever there sometimes they ask you to find the mass, sometimes they ask you to find the acceleration, and sometimes they ask you to find the external force. So these all
Mm-hmm.
three factors you can easily find by using the formula of Newton's second law of motion, which is simple F equals to ma. So is it clear? So we can move on towards our third law of motion.
Yeah.
Okay. So the final Newton law of motion is the Newton third law of motion. And this law of motion is also known as action and reaction because this law of motion tells us about the action and reaction of a body. So what Newton third law states? It states that for every action there is an equal but opposite reaction. So what does it mean? Whenever you apply some force to a body, the, that body also applies some force on your body with the same magnitude but opposite in direction. This statement tells by the Newton third law of motion. All right.
Mm-hmm.
Okay. So for every action, there is always an opposite reaction having the same magnitude but opposite in direction. This means whenever you are applying some force on either on a body which is at rest or if it is at a motion, whenever you apply some force to a body, that body also applies some force on your body with the same magnitude but opposite in direction. So this is the statement of Newton's third law of motion. So we can also say that forces always occur in pairs. Forces never occur single. They always occurs in
Pairs.
pairs. How in pairs? Because as I told you, whenever you apply some force to a body, that body also applies some force to your body.
Uh, yeah.
And when you are applying some force, this is called as the action. And when that body applies some force to your body, this is known as the reaction.
Reaction.
So action and reaction occur simultaneously. So that's why you can say forces always occurs in pairs. They not remain single. Okay.
Mm,
So example in front of you is when you push against a wall, the wall pushes back with the same equal force. Okay.
mm-hmm,
Whenever you are trying to push on a wall with some force, the wall never falls.
mm-hmm.
Why?
Because it's pushing force back onto you.
Yes, because the wall also pushes you the back in the same direction, in the opposite direction, sorry. Because the
Mm.
magnitude is same, that's why the wall always remains at rest. Let's suppose you are applying 5 Newton of force to the wall. The wall also applying a force of 5 newtons to your body. So 5 minus 5, the total becomes
Zero.
0. So 5 minus 5 becomes 0. So net force becomes 0. That's why the wall remains at rest. They will not move. Okay.
Mm. Mhm,
And the important thing is that action and reaction forces always acts on different bodies. Okay. How?
mm.
Because whenever you are applying action, so you are applying action on somebody. The body is different, and that body is applying reaction to your body. So your body or this body, these two bodies are different bodies. So action always occurs on other body and reaction occurs on
Not
different.
our body.
Okay, so action and reaction occurs on different bodies, but the magnitude should remain same and they occur in opposite direction and the forces always occurs in pairs. So this is all about the Newton third law of motion. So do you have any question?
No.
Okay, so this is basically the summary of all three Newton laws of motion what we discussed before. So this is the statement. So can you tell me what is the Newton first law of motion? Roughly, can you tell me?
Uh, if an object stays at rest, it'll stay at rest until an external force is added to it.
Yes. And you can also add whenever a body is in uniform motion, they always remains in uniform motion until
An external force is added.
yes. So also can you tell me Newton's second law of motion?
Uh,
What it says?
if
They tells us about two concepts that the acceleration is directly proportional to whom and inversely
the
proportional to
acceleration is proportional to the mass,
uh, acceleration is inversely proportional to the mass. The more the mass, the less would be the acceleration.
mm.
Am I right?
Yeah,
And your acceleration is directly proportional to the
uh,
applied force. Okay.
mhm.
So this tells the Newton's second law of motion, which is F equals to ma. And Newton's third law of motion.
Uh, when you put force onto something, it gives force back.
Hmm.
Well, when you act on something, it reacts back.
Hmm. So in that scenario, the magnitude remains
The same.
yes, and direction
Doesn't change.
yes, opposite direction. Okay,
Mm.
okay. So practical example of action or reaction is a gun recoils when fired. Whenever you fire a bullet from a gun, the bullet moves in forward direction or backward direction.
Forward.
Forward direction. Due to the recoil of the gun moves in the
Uh, Opposite direction.
yes opposite direction. According to Newton's third law of motion, the bullet will moves in the forward direction and the gun will moves in the opposite direction in the backward direction. So this is also one of the example of Newton's third law of motion. So is it clear?
Mm. Yeah.
Okay. So here are some quick quiz for you. So can you tell me uh, what is the statement of Newton's first law of motion? You already told me before.
Uh, that if an object's in uniform form or in uniform motion, it won't change unless external force is added.
Okay. So one thing more, can you tell me what does this uniform means? Uniform motion means?
The not changing, staying the same.
Yes, the whole motion is not changing, remains the same. Good.
Mm.
What is the formula of force?
F equals ma.
Yes, F equals to ma. This formula is derived by which law of Newton's?
The second law of inertia.
Yes. This formula is
No,
also known as law of
uh,
inertia.
inertia.
And as I told you before, Newton's second law of motion is also known as law of
Inertia.
inertia. Sorry, Newton's first law of motion is also known as law of
Inertia.
inertia. And Newton's third law of motion is known as action and
Reaction.
so here is a problem for you. You have to find the acceleration. If a force
Mm-hmm.
is 100 newtons and the mass of the body is 20 kg, can you find their acceleration?
Uh, 5 meters per second squared.
5 meters per second square. How?
Uh, Dividing by 100 by 20 to find the
Mhm.
acceleration.
Hmm, great. So can you define inertia?
The the more mass an object has, the less acceleration,
Yes.
and then the less mass, the more acceleration it has.
Yes, one thing more, if you apply more force, if you
Uh,
apply more force, the acceleration should be.
Less or more
What is the relationship between force and acceleration? Direct or inverse?
direct.
Yes, direct. Now tell me, if you apply more force, the body will accelerate with,
More power.
yes, more acceleration. So this is law. This is called as the inertia. The more the force you apply, the body will accelerate the more. The less the force you apply, the body will accelerate less. Okay.
Mm.
So if you apply more force, it means the inertia is
Uh, ex
high or
Less
low.
low.
If you apply more force, the
Oh,
inertia
it's
would be
high.
high. And if you apply less force, the inertia would be,
Low.
yes, low. Okay. So this is called as the inertia. Inertia is the natural tendency of an object to resist the change in motion. Okay. Resist the change in motion how? Because let's suppose if a body is at rest and whenever you apply some external force, that body changes their state from rest to motion. Initially they are
Mm-hmm.
at rest, and when you apply a force, they are now start moving, means they are now in motion. But the thing is that if you apply more force, the inertia would be high, and if you apply less force, the inertia would be low.
Low.
Okay. So can you give me an example of Newton's third law of motion?
Uh, Friction,
Yes.
because when you roll something, the friction gives a force that goes in the opposite direction, and then
Yes, this is also a good example. Good.
Yeah.
One more.
Uh, I don't know, but I just know that if there's more force going the other direction than the opposite direction, the object will just accelerate more.
Yes. All right. And one of an important example which I mentioned you before, a gun recoil when fired.
One third.
This is also one of the example of Newton third law of motion. Another example in front of you is that let's suppose when a person jumps off a boat, the person moves in the forward and the boat will move in the
Backwards.
yes. Let's suppose a boat is in some water and a person just jumps out from a boat. They jump forward direction and the boat will move in the
Opposite
opposite
direction.
direction. So this is also according to Newton's third law of motion. All right,
Mm-hmm.
perfect. Is there any question?
No.
Okay. So these three problems for you for an assessment you can solve.
Mm-hmm.
Okay, these are
Mm-hmm.
easy problems. In first problem, you have to find the force. How can you find?
F equals ma.
F equals to ma. So simple. Again, mass is given, which is 10, and acceleration, which is 3.5. You just have to multiply 10 by 3.5. You will get your answer. And in second problem, what you have to do, an object experience 50 Newton of force. So in that scenario, the force is given, which is 50 newtons, and the mass of an object is also given, which is 10 kilograms. You have to find the acceleration. And you know acceleration equals to F divided
Uh,
by M.
M. Yeah.
Yes. So 50 divided by 10, you will get your answer. And in last, you have to explain each of the Newton's three laws of motion with one
Mm-hmm.
example each. Okay.
Mm-hmm.
Any question regarding today's lecture of Newton's laws of motion?
No.
Okay, so you can revise this lecture at your home.
Right.
Okay. So
Right.
our next lecture would be regarding mass versus weight and free body diagram. Our next lecture would be tomorrow at the same time. Okay.
All right.
So if there is no question, just wrap up our today's lecture.
Okay. All right. Thank you.
Take
Bye.
care. Allah Hafiz.
Office.
Allah Hafiz.